After Debbie stormed the East Coast, our meteorologists got to work to see how the storm impacted us right here in Hampton Roads. Meteorologist Evan Stewart explains how advanced technology helps take a closer look at storms and the damage they cause.
Weather radar has come a long way over the decades. As computer technology has advanced, so has the radar, giving us better resolution and additional capabilities. In the late 1980s, the National Weather Service launched a major upgrade to the National Radar Network, installing over 160 new radars across the country. Now, these new radars allowed us not to just see the rain, but how the raindrops were moving, detecting rotation within a thunderstorm. And by the early 2000s, additional upgrades allowed us to see the precipitation in 3D. It's called dual-pol or dual polarization radar. Now, prior to the upgrades, the radar's transmitter would just send out and receive a horizontal pulse of radio waves. But now the transmitter can send out both horizontal and vertical pulses. By sending out dual pulses, we now have a more in-depth information about the size and shape of objects inside of the storm. The radar can distinguish between rain, hail, and snowflakes inside a storm. For example, big heavy raindrops, they'll be flat and wide, while hailstones, they're a little more spherical. The same principle allows us to determine whether a radar return is something non-meteorological. Using this filter called the correlation coefficient, or the debris detection, we can find objects that have a different size and shape from normal precipitation. This could be bugs, birds, or even debris from a tornado. It's something we saw last week as the remnants of Debbie produced nearly 24 tornado warnings across the region. Several of the radar returns showed the possibility of some debris being picked up by the potential twisters.